Hi and welcome to this last unit of this course in perception for ROS in Robotic Night Academy platform. In this unit we are going to talk about people tracking. So people tracking is a very important skill for robots that interact with people, especially in public environments, where you need that the robot goes to a place and you have to show it the way. So you normally say, hey, follow me, and then the robot should follow you around an environment. You're going to learn this in the simulation that you used in the unit for face detection. The only difference is that you have facing the person facing the other way around, but you will have to move it in the same way with this ROS launch. You can move it with a keyboard or publishing into the topics. So there, you can turn it around. Yep. And also ROS topic list grep stand, I think. Stand. Yeah, you can publish in this topic to move the person around. Okay. So from there, clear. So what are we going to use? So as many other detection systems, we are going to generate a cascade system. So a system that bases its detections in a combination of different detection systems so that the final result is more robust than if you only used one of the systems. The first step is, as always, you have to create your package, in this case my people tracker package, with these dependencies, geometry messages, people velocity tracker, and ROS spy. Once you have it, I have it already here, okay, we are going to create leg detector. So the leg detector is the most basic way of detecting how a person, detecting if you have a person in front of you or not. Good things. The good thing is that you use only laser. You don't use any visual system. Drawbacks. Well, the basic drawback is that you have a lot of false positives in this detection system. So obviously, you have to combine this with other systems. Why do you have false positives? Well, because it's based on detecting a pattern here in a U-shape pattern of the lasers. Let's have a look. So we launched the RViz, and as you can see here, I've already set up, I have the laser topic set up. And you can see that where the person should be, you have a U-shaped detection. This and some pattern recognition of how these dots, these detections move, you can recognize it's a person moving. Depending on how good the algorithm is, it will detect better or worse. Okay. So how do you do it? Well, we are going to use a package called leg detector. You guessed it. This leg detector package is in the ROS package system. You have all the documentation here. And we are going to talk about it. So what you have to know, you have to give as scan the base scan topic, because that's the topic where the laser is publishing the laser data. Then this is not important for you right now. You can leave it as it is. And here you're starting the leg detector, which takes in the scan and also it takes in a configuration file. This configuration file will allow you to change some parameters. We are not going to talk about it, but you can do a ROS CD to leg detector, have a look, and even make your own custom file. Finally, you have this part, which now it doesn't make a lot of sense, but you'll understand it maybe later. But what we are doing here is this leg detector outputs a kind of some data, okay? This data is in a format, but in order to make this cascade detection system with many algorithms detecting different things so that we detect in a whole a person in a robust way, we need some common ground, and that common ground is publishing the data, the results, in the same format. So in this case, we are going to use pose. We are going to publish poses. Because this one doesn't do that, we launched this detector message to pose array, launch to pose array, so that it converts that to this pose type, and therefore you can use it afterwards combined with other systems. So now what we're going to do is launch the leg detector just to see these topics. And for example, you have this leg tracker measurements, which is of type. Let's have a look. So there we go. People messages, position measurement array. And on the other hand, we have this leg detector, which is the same data, but it's in pose array. This you will need it for the cascade detection afterwards. Okay? Okay, so the exercise is create a script, exactly what I did, launch it, and see how it detects, how it performs. I'll tell you that it won't perform as well as you might think, depending on how you move the person, depends on a lot of things. So, the next step. The next step is doing a detect of the upper body. This detector is launched by this upper body start. For example, you can do something like that. And let's talk about it. So let's go to the code and let's go to body start, upper body. This is something more complex here. Essentially, we have three parts. So we have the argument part, and then we have these two launches. The first launch, what it does is do a ground detection. So it detects the ground through indirectly through the surface detection that we did in object recognition. It's more or less the same. So it detects the floor, and with that it allows afterwards to detect the upper body better. So if you see here, let me have a look. And there we go. So we have the ground plane here. And the ground plane is the topic where we will publish the data about the ground plane. And this upper body will use it to make a better detection. Okay? And in this case, what we're doing is detecting the upper body part. So let's say the shape of the head and shoulders. And to do that, we have to give it loads of data. But the important data is the camera, basically. So you need to give it an RGB information from a camera, and you need also depth information. Then here you're giving the topics where it will be published and so on. Nothing very strange here. And then you have the machine, user, and so on. That we won't talk about that yet. And that's it. So now we are going to launch this, see how it performs, and see what it can give us. Okay, so let's launch this. First, we'll have to close the leg detector. Okay, now the upper body start. Okay, and now we are going to do a ROS run RQT image view, RQT image view. And what's the point? Well, if we go here, you'll see that one of the topics that we use and we will write on is this upper body detection image here. Upper body detection image. Here, what we will do is impose or put on top, we will put on top the detections of the upper body with the image data. So if we go here and we select upper body, let's see, upper body detector image. Okay. So we can't see it now. Why? Because it's too close. So we're going to move the person. Let's go and retrieve our beloved script to move it around. There we go. Let's move it around, I don't know, around here. Yeah, I think that's okay. Okay. There you have it. So now it's detecting the shape of the head and the shoulders, and it's giving us a detection. Perfect. So as you can see, this is giving us a better detection than the legs. So good for that. So let's go again. Whoopsie doopsie. So this is more or less what you should have. Beware that this, if you turn the person sideways, it won't detect anything because it's not detecting any pattern. But apart from that, it's quite robust. So the detections and the topics that are published, we've seen the upper body detector image, but of course you need some kind of data, of position of some kind. So you have this marker array, you have these detections, you have bounding boxes centers, as you wish. For example, detections. Let's have a look at the topic of detections. For example, ROS topic echo, and as you can see, we are getting the position in the frame, so 210 minus 46 with height. This is the, let's say, the box that we are going to generate, and the distance. So we have position in 2D and then in 3D because it's telling you the distance. So you have a three-dimensional positioning. So great. That's fantastic. So now, as exercise, you have to do exactly the same thing I have done. So launch it, detect, see what kind of data you get from the topics, and continue to the next one. So when you're finished, we are going to go to the pedestrian detector. So this detector is more, it builds on top of what we've done. So before continuing, we're going to stop. Okay, and we can continue. So, pedestrian detector, this one builds on top. So uses the detection of the ground and also detects the upper body. So let's have a look. So it's using, let's have a look here, because it's, I think it's easier to understand. So here we have loads of arguments which essentially are the same as the upper body. Some other data, like for example visual odometry, where it will be published and so on, and where it will be published this, so the MDL people tracker. These are the topics that we have to see for the data of the detections. Yeah. So we are using visual odometry from the camera and so on to make detections. Then the ground plane, which is the same one we used in the upper body detector. Then we are using the upper body detector. And then we are using also this MDL people tracker, which, as you can see, it's using the ground plane detections and the upper body detection. So it's building on top of what we did, except the leg detectors, which is not being used here. Understood? This is deep, and of course, this is a basic course. Of course, you can go deeper, you can know exactly which parameters and so on, how to tune it and so, but like this, it will work. And it's more than enough to know how to make this work, and then you can build on top of this. So, there we go. So you should see something like this. As we had in the upper body, we have the same version in the MDL. Let's have a look. So I'm going to launch this. It's MDL. Yeah. Let's start. Okay, now we got it. Now we're going to, for example, see the image. It's a fast way of seeing if it's making the detection. So here we're going to look for, there we go, image. Okay, now we are getting a detection. So as you can see here, you have a bounding cylinder around the person. So if we move the person around, let's have a look. Let's move person a bit further. You can see the box that it moves around the person. Not only that, but if we continue, let's give it a bit of boost. Yeah, so the box becomes smaller. So we have distance information like in the upper body, and you also have some kind of information of the orientation, which that's good. That's really good. And that's it. So the exercise that you have to do is exactly the same one as in the upper body and leg detectors, is do exactly the same thing I have done here. So launch it and see and compare the data. So the data, you'll have the same thing, people tracker, people array, and markers and so on, to have the data in 3 dimensions. Okay, and finally, how we combine all the systems together. So this is the cascade that we've been talking about. So by itself, the upper body or the pedestrian detector or the leg detector don't work as well as combined. So what we are going to use is a very old trick, which is called Kalman Filter, more precisely the uncentered Kalman filter. The same thing. This is a basic course, so we won't go in depth in the theory of Kalman filters and so on. The idea would be a Kalman filter is a system that allows us to combine different sources of information and give them a weight. And the weight is based essentially on how good the data detections are. So, for example, let's say our upper body is a good one, so it makes a lot of predictions, but maybe it has a lot of noise. So maybe it fluctuates a lot in space. So in this case, we are comparing all the systems with the pose array that it gives us. So in this case, in the upper body was upper body detection bounding boxes. In the leg detector is the two pose array. In the mobility A detector, which we won't use, and this one is the MDL people detector, which is the MDL people tracker. So depending on how good the data is and the position that each one gives us, we give them a weight. This weight is based on the Cartesian noise params. So how much noise all these detections have. How do you do that? How do you get these values? Well, in theory, what you should do is first execute just one. So for example, the upper body detector, save the X and Y data detections, so the position in the plane, and once you have it, because it doesn't matter where it is up or down, it doesn't matter. The important is the person where it is in the plane. Okay, so you save the X values and the Y, and you calculate the mean and the standard deviation. Okay, and you'll get something similar to this. Okay, and based on that, that's what you're going to put here as noise. Okay, so maybe you make detections like here, so you won't have a lot of standard deviation. So it's a good detection because when it detects, you're sure that it's there and it's not like 1 meter to the left or 1 meter to the right. Okay, if it's too large, then it makes a lot of detections, but it fluctuates a lot in space. Another way of doing it is just give it these values, for example, and then try changing them to see what effect it has in the detection system, as you wish. This is basically the detector's YAML that you will need to combine all these detectors together. Okay? This detector's YAML will be used in the People Tracker custom launch. I know it's a very long name, but basically you see detector's YAML, it's here. And what we are going to do is use two launches. One that it's called People Tracker Custom Launch, which is this one, which combines all the systems. So you have visual odometry, you have the ground plane, you have the upper body, the pedestrian tracking, and the leg detector, and extra one, which is the base people tracker. There we go. Then to pose array for the leg, and then some loggings. Okay. And then we are going to use this start people tracker custom that will allow us to put the values that we need for each robot. So in this case, these are the values. In other cases would be something different. Okay. So here, for example, we are taking our own My People Tracker package config detectors YAML, which in here we're taking the system one. I think I showed you before, right? Okay. Yeah, here. Base tracker. Fantastic. So at the end, what will you have at the end, the thing that you will have is a people tracker people, and pose array and positions. And those topics are the ones that tell you, okay, here you have a person, based on all the information that I got from all these systems. Okay? And to represent it, in RViz, we are going to use this marker array. Yeah? And you should get something like this person here. It's a marker made in the shape of a person, which combines all this data together. Okay, so let's launch it and see what happens. So I'm going, this is stopped. This also, yeah, this also. So now I'm going to start people tracker custom. Start people tracker custom. We wait until it loads everything. Okay, we have it. Now we launch our viz. And to make things easier, I have already this configured, and I'll show you how to do it, but that way we'll go faster. So here in the RViz, I'm going to load a config file, which is called, let's see, people tracker. There we go. Discard changes. Now it's detecting. There we go. So here you have everything you can get, and we are going to have a look at this. So here what you're seeing is the lasers, a marker, another marker. Here you're seeing the camera with everything that it's being detected. And then here you have an extra image for the pedestrian. So let's disconnect some so that you can see it better, because, okay, let's disconnect this, and let's get rid also of the camera. Well, like this is okay, yeah? I think it's okay. So we have the robot model, the laser scan, which is here. Then we have the marker array, and we have this marker array and another marker array below. Okay, so we're going to disconnect this one for the moment, and we are going to talk about this one first. This one is getting the people tracker marker array. That's what it's getting, and it's put on top of the camera, the RGB in this case. So now what we're going to do is we're going to put this here, this around here. We're going to put this around here, and I'm going to move the person around, okay? So let's move. As you can see, it corrected the position, the orientation. Why? Because it's based on the orientation, it's not based on the person, on real person, but on the direction of the movement. So if it moves in this direction, possibly it's because the person is facing this way and it's moving in this direction. So that's the orientation that a person should follow. If I move on this then it turns around. There we go. It turns around, and then it says, okay, it's moving in that direction, and so on. If I turn around, I start turning. So you see that the orientation is primarily based on the speed and movement of the detections. That's all. So it's And now, because it changed, you see, now it was sideways and he lost all detections, absolutely all detections. And when it turns and faces back, you regain it again. So you see that it's not perfect. So there's place for you doing it better, which will be the exercise that you'll do, an extra exercise for that. But first, we're going to close this. And the exercise that you have to do is execute this and see in RVs everything. So you'll have the marker array, you'll have to add this marker array and see exactly the same thing that I showed you. Plus, now put this box. This box is based on the upper body detection, which in one of the topics, it publishes also a marker array. So you can put, in this case, the marker array published is a green box. Okay? Fantastic. So now the extra exercise. You'll have to implement a new detection system and add it to the detection piles, to this YAML file that we talked about. Which kind of detection? It depends on you. I would recommend you that you use something that you have learned in this course. For example, blob detection. It would be easy for you to implement. And for example, you can do a blob detection of white colors. And that way you can track the person with white t-shirt. In this case, he has a white t-shirt, so perfect. And that way maybe you can remove that error that when he turns sideways, you lose all detections. Because you'll lose even the leg detectors. Okay? So that's my recommendation. But you can do anything you want. Even if you're working with AI, maybe you can do something spectacular. Okay? So that's the end of the unit. Just talk about the project. So in the project, there you will have to make the eyeball robot follow the small boy, Timmy. And Timmy is a person that it's moving around in space. So you'll have to track the person and try to follow it. It's not easy, but sure you can manage it. So that's the end of all the theory of this course. So congratulations, you now know how to do all the stuff, basic stuff for perception that you need to make your robot move around, detect objects, follow persons, detect who is talking to, and much, much more. So now the only thing that's left is to do the project. So see you there.